Hello guys, welcome back to Maths with Mars. So today we will be learning about representation of data, which is a chapter of statistics. So let's begin. So first of all, we need to understand the term data. So data basically means information. Let me just write it over here. Data is information. Okay, and the data could be divided into two main categories. It can be divided into, let me just do it over here, qualitative and then quantitative. Okay, so we will be dealing with quantitative data for this video. Okay, so the quantitative data could be further divided into two main categories. These are discrete and then we have continuous. Continuous. Okay, so first of all, let's discuss these terms. So qualitative data means the non-numerical data, which can be anything like color or something that cannot be put into numbers, whereas quantitative data is the opposite, something that can be quantified. For example, the number of children in a class, it could be 4, 5, a number is attached, right? So that is quantitative data. The quantitative data could be further divided into discrete data. Basically means the data which can be referred to in exact form. For example, I can precisely say, in the very precise form, I can say that there are 4 children sitting in the class, right? And I can say that there are 20 things lying on the table and things like that. And mostly there is this discrete data is referred to as data without decimal numbers. However, there is a little ambiguity in that case, because money, for example, is written as $195.20. Okay, so that is discrete data because this is precise and exact amount, but this is written in point form, and that is a convention. So this is the only discrete data that can be written in decimal form. Now let's move on to the continuous data. For continuous data, I can say that it is the data which is not in precise form. For example, if I have a data represented over here of marks, let's say marks of students in a class, and the frequency over here. So let's say the marks of from 0, I will just denote the marks from x. Okay, from 0 to greater than equal to x, greater than equal to 40 are 3, and then 40 x 40 x and 80, let's say, is 5, and then 80 x 100 is, let's say, 2. You can divide these marks into further categories, like I have just drawn 3 right here, right? But you can do like 1, 2, 3, 4, 5, and you can go on and on. The more the values you have, the more precise is your data, because over here that I have taken a range of from 0 to 40, which means a range of 40 marks. So this means that there are 3 people who have scored in that range, but that is not a very accurate representation. As we say in discrete terms, that is not a very precise definition. Okay, because a person can also score 0. All 3 could also have scored zeros. All right, and similarly all 3 could also have scored 40s. So that way the number of 3 won't be very representative of the sample of all these students who have scored from 0 to 40. All right, so therefore the more precise the value, the better. For example, if I did values from 0x10, then the chances of error would have been lower, right? So that is for continuous data. Now moving to discrete data, I can say that discrete data is exact data. For example, if I have x and the frequency of x, I can write it as 4, 5, 6, and 4 as the frequency of 2, 5 has a frequency of 3, 6 has a frequency of 8, let's say. And this, for example, this could be I can just change it to 1, 2, and 3. For example, this could be a three-sided die. All right, and this it means that 1 has come twice. You can write it in raw form. This is raw form, and this is organized form. This one is raw form. So here I could so this is discrete data, and this could be anything like it could be a three sided fair die, and the probability of the times 1 has been rolled is 2, the times 2 has been rolled is 3 times, the times 3 has been rolled is 8 times. Okay, this is organized form in a table. Okay, so but we can also write it in raw form, which would be that it is 1 2 times. Okay, so I can write it as 1 1, then it could be 2 2 2 because it is 3 times, and then for 3 it could be 3 3 3 and so on 8 times. Okay, so that would be the raw form for this data. Okay, so that is for the discrete and continuous data. Now let's move on to another thing that you may have already studied in the previous lessons, but this name may sound familiar. So I am talking about measure of central tendency. This name may sound very confusing or a very big word, but this basically refers to mean, median, and mode. Okay, so what does this mean, the measure of central tendency? So its measure of central tendency basically means the value that can be used for to represent a data, and it is only one of the values. Let me give you an example. For example, if there is a class and there have been surveyed about, let's say, a new item in the canteen. All right, so the amount it is basically a yes no question. So let's say that the classes of 14 students and 8 say yes and 6 say no. So here the yes would be considered, and that is because the yes is the mod over here. However, and in this case, the data could be represented by the mod. However, this may not always be the case. For example, if the data is, let's say, about a policy of a prime minister, and if the entire population is against the policy, and only let's say 5 people are very large generalization, or but let's say only 5 people are with the policy, so but still the width will be considered because of their position. Okay, so position matters over here, and position is matters in median. Okay, so in that case, in that data, the median is the measure of central tendency or the representative of the data. Okay, so that is for the measure of central tendency. If to calculate mean, you can from, let's say, I'll take the example in previous one, from x is 1 2 3, and the frequency is 238. Okay, so this is to calculate the mean. I can just do it simply. We have to make another column, so it would be fx, which means 2 2 times 1, which is 2, 3 times 2, which is 6, 8 times 3, which is 24. Okay, why did we do fx? For example, if we just refer back to the raw form over here, if there are two ones, that means the mean would be of these two, right? And when we add these two, then we will add say 2 3 times, so that would be basically 6, right? This would be 2, this would be 6, so this is the 2, this is the 6, then we add 8 8 times, so that is basically the numerator of our mean function, mean of our mean of the data. Okay, and for the denominator, what we have to do is the total number of frequency. For the numerator, we first do the total number of fx. The total sign or the sum sign can be represented as this sigma notation, and 2 plus 6 8 plus 24 is 32. Okay, so sigma fx is equal to 32, and for sigma f, that would be equal to 2 plus 3 plus 8. Okay, so it would be 5 plus 8 13. And for mean can be represented as this dash above the x. For the mean of x, it could be it will be 32 over 13, and that is the mean. Okay, for continuous data, you can't exactly calculate the mean, but you can estimate the mean instead. Okay, for let's say I will just do it like this. It is x, and then we have 10. For then we as 10 x 20 x 30. Okay, and the frequency over here is, let's say, 5 sorry, we have 5 10 and 20, let's say. So here we have a range of x, right? And the frequency of 5 could be anywhere between 0 and 10. So first of all, we will calculate the average x. Okay, so 0 plus 10, which is 10, divided by 2, which is 5. Okay, I have just calculated the average over here. This, the maximum plus the minimum, divided by 2. 10 plus I could write it as 10 I could write it as 10 plus 0 over 2. Okay, and that would be the 5, which is the average. Why do we take the middle value? Because that way the chances of error are low. If we take 10, then and all the 5 values over here are 0, then the chances of error would be high. The chances of error, the deviation from the value would be of 10. By 5 we even out, and that is the minimum possible difference that can be occurred. So to minimize the chances of error, we take the average value. For 10 plus 20, we will take 15. For then for 20 plus 30, we will take 25, basically the middle. Okay, so now we will calculate the mean in the same way, by f of x, then sigma f of x, and then we will the mean of x would be sigma f x over sigma f. That is it for the video. Thank you.